Hello everyone. The title of this video is section 6.5 on solving polynomial equations by factoring. So in this video I'm going to be going over a version of the Knewton Alta assignment for section 6.5. Please understand that the version I'm going to be working on in this video, the questions I will be seeing, are not necessarily going to be exactly the same questions you will see when you work on the assignment. But the objectives are the same, the types of questions are similar, and the way I would go about working on them is similar to how you should. So I'm hoping that watching me go through these several examples helps you in some way when you're working on the assignment on your own. Alright. So here's the assignment page. Now you will not see the word preview. You'll just see the title of the section and the mastery bar showing you how far along you've gotten. And the objectives. Now this assignment has 2 objectives. Question below, and every question will have a feedback button. You will not have the instructor cheat button, but you will have the more instruction button, which is useful for when you're struggling with a question or an objective. Click on more instruction and you'll see further reading material or videos that may help you with that particular topic. Alright, so this first question, the objective is use the zero product property to solve a factored polynomial equation. So you see in this first equation, and this is what we want to do for every polynomial equation, we want to get a completely factored polynomial on one side of the equal sign and the number 0 on the other. Alright, now the nice thing about this objective is that the polynomial on the one side will already be in factored form, and you have the number 0 on the other. Alright, so I'll write this down and we'll talk about the zero product property. So as I mentioned, this is what we want in every polynomial equation. I want a completely factored polynomial on one side, or just factored. Alright, this would be the polynomial 11q squared plus 4q, but with the q pulled out, right, totally factored. And then on the other side of the equal sign, we want the number 0. Right, it has to be the number 0 in order for this to be applied. This thing called the zero product property, which I'll write off to the side. The zero product property states the following. If a product equals 0, now remember, a product is some sort of multiplication, like here, q times 11q plus 4, right, the product of 2 factors. If a product equals 0, and only 0, okay, not any other number, if a product equals 0, then at least one of the factors of that product must be 0. So at least one of the factors must be 0. Okay, there's the zero product property in words. Now I could also write this in symbols, right? If, say, A times B equals 0, I have a product equal to 0, then either the factor of A is 0 or the factor of B is 0, or both, but at least one of those factors of the product must be 0. So again, this is an equivalent way of saying that. And it doesn't have to be a product of just two factors. This is any product. You could have A times B times C equals 0, then either A equals 0 or B equals 0 or C equals 0. Right? And I could add on as many factors of the product as I wish. So like I said, this is exactly how we want to write every single polynomial equation we're working with in this assignment. I want to eventually get down to a point where I have a completely factored polynomial on one side, a product of multiple factors, equals 0. It's got to be 0, right? Because if a product equaled 10, that doesn't mean one of the factors has to be 10, right? You could have 2 and 5, a half and 20, right? So like the only number this actually works for is the number 0. Right? So the nice thing about this, again, this objective, these questions, is that the polynomial is already factored for us. So by the 0 product property, and you know what, I'll abbreviate this ZPP for the rest of the examples. In order for this product to be 0, Q times 11Q plus 4, in order for that to be equal to 0, either that first factor is 0, so either Q equals 0, or the other factor of the product, 11Q plus 4, equals 0. So we're going to take our polynomial equation and kind of split it up into two easier equations, and you solve these, and those give you, and then of course check your solutions back on the original. Now Q equals 0, when you solve it, it's just Q equals 0. And there's a solution of that equation. 11Q plus 4 equals 0. I would subtract 4 divided by 11. We'd get Q equals negative 4/11. Right? And then don't forget to check these in the original equation. Always check back in the original equation. So when Q equals 0, you'd have 0 times 4 equals 0. That's true, right? Because anything times 0 is 0. When Q is negative 4/11, you'd have negative 4/11 times 0. Right? The second factor would be 0 equals 0, and that's true. So both of these are good. And if you know you're doing everything right, they should work out. So in the future, maybe if you're that confident, you know I did everything right. You probably, you should always check, right? Maybe just do a quick mental check to see if they make the true original statement true. All right, and then I could state the solutions as a solution set if I want the solution set for this equation. Just all the values of Q that make it a true statement. So you have zeros in there, comma, and then negative 4/11 is also in the solution set. So you may see it written out like this as well. And I think this is how they want us to enter things, with commas separating them. Not with the brackets though. Right? See back in the homework, they just want you to give answers. Now when they say an exact answer, that just means don't put it in a calculator. Negative 4/11. Don't put that in a calculator, because that's going to come up negative 0.363636. Leave it as negative 4/11. And use a comma to separate multiple solutions, multiple values. So like I was saying here, so here we have Q equals 0 is one solution, and then I go comma, and then I put negative 4/11. Right, negative 4/11, and that's how they're wanting us to type answers here. Okay. So simple enough, and it shouldn't matter what order they come in. If you put negative 4/11, then a comma, and then 0, you'd end up with the same result. Same answers. Great. Yeah, so easy enough there. Next question is on the other objective. Solve polynomial equations by factoring. So I already told you what we want. We want a completely factored polynomial on one side of the equal sign, and then 0 on the other side, which I don't have yet. Now in this equation, 0 is already on the other side. That's great. So I just need to factor this polynomial over here completely, which I'll write out and do. And we're trying to solve, right? So we're trying to find values of m that make this a true statement. So it's already it's almost set up the way I want. I've got my polynomial on one side and 0 on the other. I definitely want that. Right? So that's great. Now I just need to completely factor this polynomial. Right? It is not factored yet. So you may recall from a previous video of mine or other videos you've seen or the book you're reading, when the lead coefficient, the coefficient of the highest powered term is negative, I'm going to pull out the negative, the opposite of the GCF, right? The greatest common factor is 2m, right? Every single one of those terms has 2m. And because the lead is negative, I'm going to pull out, the opposite of the GCF. I'm going to pull out negative 2m. Right, so there's the GCF, or the opposite of the GCF. That's one factor, negative 2m. Times, and then when I pull out negative 2m, what would be left over would be 3m squared minus 5m, and then plus 2. And we still have equals 0. And this is, the GCF is pulled out, great. But now I'm going to focus on this trinomial here. And I'm not going to go into all the factoring methods. I'm just going to write out what this will factor to and leave it to you to figure it out. As I'm assuming by this point you know how to factor polynomials. So we have negative 2m, right, that greatest common factor, or the opposite of the greatest common factor. There's one factor. And then 3m squared minus 5m plus 2 would factor to the following. Minus 1 here, minus 2 there. Right. Would factor 3m minus 2 times m minus 1. And I leave it to you to FOIL. You got the minus 3m, the minus 2m for the minus 5m, and then the plus 2. Okay. I leave it to you to check, though. Alright, so now I have what I want, right? I have a polynomial that is completely factored on one side and 0 on the other side. So now, by that 0 product property that was mentioned, right, and I'm labeling it ZPP, if a product equals 0, then one of the factors must be 0, at least one. So either negative 2 times m, that factor, is 0, or this factor of 3m minus 2 is 0, or this factor of m minus 1 is 0. And solving each of these three equations will give me solutions to my original equation. The first one's easy enough, m equals 0. Second one, m equals 2/3, adding 2, dividing by 3. Third one, m equals 1. And don't forget to check, I'll leave the fraction for you. Obviously 0 works. You'd have 0 plus 0 plus 0 equals 0. 1 works. You'd have negative 6 plus 10 is 4, minus 4 is 0, that's true. And I'll leave the 2/3 to you to check. Replace all the m's with 2/3. And you'll see that the original statement is true. And then once again, if you'd like, you can write the solution set if you'd like, the set of all the values I can replace m with and make the original statement a true statement. 0, comma, 2/3, comma, 1. And this is also equally valid. Now they're just having us enter the numbers with commas between them. Right, back here they're just saying use commas to separate multiple values. So we're not writing the set. Don't use the set braces. It just says m equals what? M equals 0 is a solution, 2/3 is a solution, and 1, right, with commas between each of them. Right, great. And once again, read through the answer explanations, please. If you're right, you'll see that you were make sure that you were right for the correct reasons. And if you were wrong, hopefully you'll figure out from these answer explanations where you went wrong and learn from your mistakes for the future. All right, next question. So it's the same objective as the last question, just solve a polynomial equation by factoring. And look, this equation already has 0 on one side. Great. That's a good start. But the polynomial on the other side, I would like to completely factor. All right, so I'll write this out and let's do that. And then we'll use the zero product property to solve. All right, so same deal. All right, again, 0 is already on one side. Fantastic. That's what I want when I'm solving these polynomial equations. Now I would like to completely factor the other side. Now the lead coefficient is negative, so I'm going to pull out the opposite of the GCF. Now the greatest common factor of these three terms is just 1. So I'll start off by pulling out -1. So we have -1 as one factor times, and if I factor out -1, then you have 12, negative n. My apologies, every single one of these has at least n. So sorry about that. Every single one of the greatest common factor is n. Because the leading coefficient is negative, I'm going to pull out -1n or -n. Alright, sorry about that. So minus n is one factor. And if I pull that out, then you'll have 12n squared minus 7n plus 1. And now I'm going to try and factor this trinomial. 12n squared minus 7n plus 1. So this would be -n. And then this will factor, and again, I'm assuming you know how to factor. I'm not going to go into all the detail. I'm just going to write out what this is going to factor to. It's going to factor to 3n the factors are 3n minus 1 and 4n minus 1. And again, I leave it to you to check that. Alright, so now I have taken this polynomial on the left and factored it completely. And now I have what I wish for. Right, I have a product equals 0. A completely factored polynomial equals 0. So then by that zero product property, which again I'm abbreviating ZPP, when a product is 0, at least one of the factors is 0. So either that minus n factor is 0, or the 3n minus 1 factor is 0, or the 4n minus 1 factor is 0. And then I solve each of these, and there will be my solutions. Here, just dividing by -1, get n equals 0, which is obvious. 0 plus 0 minus 0 equals 0. That's where that works. Solving this one, add 1 divided by 3, n equals 1/3. And again, check it, make sure I'll leave the fractions to you. I don't feel like doing that here, but if you replace all the n's with 1/3, it should work. the original statement should be true. And then this last one, adding 1 and dividing by 4, n equals 1/4. And once again, I leave it to you to check that, but they should work. So 0, 1/3, and 1/4 are the solutions, and I'll enter those with commas between them, right? 0, comma, 1/3, comma, 1/4. And submit. Great. All right, and read your answer explanations, please. Next question. All right, so we're back to the easier objective, I feel, because they already have the equation set up the way you want to use the zero product property. You have a totally factored polynomial on one side and 0 on the other. So I'm just going to talk this one out. Now I'm going to write this one. If a product equals 0, like this does here, then at least one of the factors of that product must be 0. Well, if 4q plus 5 is 0, then q must be negative 5/4. So that's one solution, comma. And then the other factor is q minus 5. And if, sorry about that, if you can hear the dog barking, I apologize. Q minus 5. If that's 0, then q must be positive 5. So my solutions are negative 5/4 and positive 5. And I'll put commas between those. Right? Yeah. So I'm going to do that with the rest of these from this objective. Right? This objective should be quite simple. You're just trying to, you'll have a factor polynomial on one side equals 0 on the other, and you're just trying to think of what values of the variables will make each factor 0, and they should be simple. All right. So here's another one, same objective, and look, and now this isn't completely factored, because you could factor a 2 out of this first one, but 2 is not going to be 0, so that's not important. All right, it's factors with variables that will be important to finding solutions. So again, I have a factored polynomial on one side, again not completely factored, but a factored polynomial equal to 0. And using that zero product property, right, a product is only equal to 0 when at least one of the factors of that product is 0. So when is 6a plus 2 equal to 0? Well, that'd be negative 2/6. But negative 2/6 is negative 1/3. All right, when you reduce it. So negative 1/3 is one solution, comma. And the other factor of this polynomial, 8a plus 7. When is that 0? That'd be when a is negative 7/8. You would subtract 7 divided by 8 if you were setting that equal 0. So my solutions to this one are negative 1/3 and negative 7/8. Great. So again, pretty quick stuff here when it's already a factored polynomial on one side and 0 on the other. Alright, so this one I'll actually write out because I've seen too many people get confused by this. But it's the same thing where the left side is already a factored polynomial. This one's actually completely factored, and 0 on the other side. You just have to remember here that 2a minus 7 to the second power, raising to a power just means multiply by the same thing multiple times. So 2a minus 7 to the second means the following. That's 2a minus 7 multiplied by 2a minus 7 again. Right? The second power just means I have two factors of 2a minus 7 equals 0. And then I have exactly what I want, a product equal to 0. So then by that 0 product property, at least one of these factors is 0. So either 2a minus 7 equals 0, or 2a minus 7 equals 0 again? There's no need to repeat it. You know, I've already written it once here, 2a minus 7 equals 0. There's no need to write 2a minus 7 equals 0 again. So I'm only going to get one solution out of this. A equals 7 halves. Just the one solution. Now, because that would have repeated, sometimes this would be referred to as a repeated solution or a repeated root of this equation. And the number of times it is a solution would have been twice, and they would call that the multiplicity of the solution, but I'm not going to get in all those fancy words. Right? Don't worry about that stuff. Just know that the only solution here is positive 7 halves, right? So no, my answer is just w equals 7 halves. Well, I put a, didn't I? Whatever. W, a. Sorry, I wrote a instead of w, but w equals positive 7 halves. This is the only solution of this equation here. Great. So that objective now with the using the zero product property where they already give you a factored polynomial on one side, 0 on the other, that's done. That should be simple. Alright, and then we got 2 more questions to do where we're solving the equations by factoring ourselves. So far it's been pretty nice where they gave us the whole, a polynomial on one side and 0 on the other. Just be aware that, in some questions you might not have 0 on one of the sides. So just make sure you're taking everything to one side so that you get 0 on the other side, and then simplify the polynomial, and then factor that polynomial. Just please be aware that that's not always, they won't always be so nice to you as they're being so far. Okay, so again, everything on one side, 0 on the other, and now I'm going to factor this polynomial. Now q squared plus q just has a common factor of q, so I pull q out, that's one factor, and then the remaining, if I factor a q out, the other factor is q plus 1, and that's it. That's as factored as that polynomial is going to get, and I have exactly what I want now. A factored polynomial equal to 0. A product equal to 0. And then by that 0 product property, right, ZPP, at least one of these factors is 0. So either the factor of q equals 0, which is already solved for, and then you can check that solution, 0 plus 0 equals 0, that works, or the other factor of this polynomial, this product, q plus 1, is 0. And solving this gives me q equals negative 1. And again, you can check that pretty easily. Negative 1 to the second is positive 1. Positive 1 plus negative 1 is 0. That works as well. So my solutions to this equation are q equals 0 or negative 1. So I'm putting a comma between those, 0, comma, negative 1. Great. Alright, so probably just got one more of these. Alright, so once again, they're giving me a polynomial on one side, 0 on the other. I'll tell you one more time here, if you don't have a side with 0 on it, subtract all the terms, get rid of everything from one side so that you do have 0 on one side, and then you simplify the polynomial on the other side, combine like terms and junk and multiply it out, combine like terms, and then once it's simplified, factor it completely and use the 0 product property to find solutions. Alright, so again, I'll write this out. So everything on one side, simplified polynomial on one side equals 0. Fantastic, that's what I want. And now I want to factor this polynomial completely. Alright, so the greatest common factor is 2x. Right, the greatest common factor of all 3 terms is 2x, but as you've seen in earlier examples, the lead coefficient is negative. So in those cases, I do like to pull out the opposite of the GCF, right? -1 times the GCF. So I'm gonna factor out -2x, and that opposite GCF or GCF, whichever one you pull out, that's one factor. And then what's remaining would be 2x squared plus x minus 6. And that would be the factor remaining. And now I'm going to factor this trinomial a little further. Again, I'm not going to go into all the details. You should know how to factor by now. So -2x, and then this would factor this 2x squared plus x minus 6. You have 2x in one, x in the other. Then a plus 2 here, minus 3 here, because that'll give me positive 4x, minus 3x for the positive 1x, and then you got the minus 3 times 2 for the minus 6. All right. Great. So now I have a product equal to 0, right? A completely factored polynomial on one side, 0 on the other. This is what I want. So by that 0 product property now, right, ZPP, at least one of these factors must be 0 in order for this to be true. So either -2 times x is 0, or 2x minus 3 is 0, or x plus 2 is 0. Solving each of these gives me the solutions, solving and checking, of course, but again, I'll leave the checking part to you, but they should work. So x equals 0 is one solution. X equals, positive 3/2, add 3 divided by 2 there, and subtract 2 from both sides on this. X equals -2. Right. And again, I'll put the little check marks to remind you to check. Check back in the original statement, see that it makes it true. So 0, 3/2, and -2 for this one. And that's all I'm doing, is entering those values with commas between them. 0, comma, -3/2, -3/2, comma, -2. Nope, not -3/2. I said positive 3/2. I said positive, but I typed negative. Double check your answers before you hit submit. There's a lesson there. And wonderful. And that should be it for this assignment preview. And as I say at the beginning of these videos, the version of the assignment I just went through is not going to be exactly the same as the version you go through, right? But the objectives are the same. The types of questions are the same. The way you would do them is the same. So I'm hoping that seeing me go through these examples here help you out a bit, in some way when you're working on that assignment on your own. All right, and thank you very much for watching.